So new element F can be pushed into this stack. So before to push, we have to pop out the D and store into the visited list or visited array, and the new element F will be pushed. So F will come over the C. So right now, who is the top position? F is the top position. Again, we have to think, that is from F where we can move, that is D and E, and D is already into the visited array, so we have to ignore this. So this should be written into the process. You have to written, that is, if D is already into the visited array, we have to ignore this, or if D is already into the stack, so again we have to ignore this, and the new element only push into the stack. So during the process of F, so from F we can we can move to the D and E, and D is already into the visited visited list or the array. Okay, so D should be ignored, and the new element E should be pushed into this stack. Before to push, we have to pop out the F and store into the visited array or the list. Okay, so right now E is pushed over the C. So right now, who is the topmost value? That is E. So again, from E we can move F and C. From E we can move F and C. Because of C is already into the stack, so we have to ignore this. Because of C is already into the stack, so we have to ignore this C. Okay, and as well as F should be ignored because F is already visited. Okay, so this time we will not push any element. Apart from, we have to pop out the E. So when we pop out E, so E should be come into the visited list or visited array, but no new element will be pushed into the stack. So again, right now, top will decrement its value, and now the top position's value is C. So again, we have to check or to consider, that is where we can move from C node, and that is A and E. So A is already visited array, and E is also into the visited array. So no new element can be pushed. Only the pop operation can be possible, and that is C will be removed or pop out from the stack and store into the array, visited array or visited list. So right now the stack is empty. So if stack is empty, so that means the operation is over, and right now all the six node is already visited. Okay, so the sequence is A B D F E C. Clear? And this is the program. Here is the comparison between DFS and BFS. So this DFS stands for depth first search. BFS stands for breadth first search. DFS can be done with the help of stack, that is the LIFO rule. The you can see here. This is the wrong. This will be LIFO, last in. So that is the meaning is last in, out fast, whatever, and fast in, out fast. So we normally follow LIFO, that is last in, fast out, and FIFO means basically fast in, fast out. Okay. In DFS has higher time and space complexity because at a time it needs to backtracking in graph for traversal. What is the meaning of backtracking? Basically, when we use the DFS, so the last inserted element or post element will be considered first. So that is why this is called the backtracking. And in BFS, the space of and time complexity is lesser, as there is no need to do the backtracking. Next point, DFS is more faster than BFS. The same, basically the meaning is same. BFS is Okay, higher time and space complexity meaning means is the complexity. This indicates that is a faster, but BFS lesser complexity that indicates the slower. So that is why DFS is more faster than BFS. BFS is slower than DFS. DFS requires less memory compared to BFS, and because of you know uh, in stack you can see the stack always we use the minimum the from 0 1 whatever the remove that is also the position the value is removing, that means that particular memory is again we can use, but in queue this memory this room is already deleted because front is increment its value, but still these are into the uses. This memory are already uses, so the memory will be uh, required much than the DFS. Okay. Now DFS is not useful in finding shortest path. B- BFS is useful in finding the shortest path. Example A B C D E F, that is a tree. A B C D E F, whatever the tree is. Now the answer is if we consider as A, from A we can move B and C. So in DFS we have to write the A is visited, then B and C. So if we consider as a C, first we push C and thereafter B. So next time from B we can move D. That after that we can move D and B will be removed and D will be pushed into stack. Then from B we cannot go anywhere, so B will be there. But C, after deletion of or pop out the D, the C is the topmost value, and when we see consider that E and F can be pushed into the stack, so C will be deleted and this C will be into the visited array and new element E and F will be pushed. Okay, and thereafter E from the E and F, no new element, no node are connected, and C is already visited, so no new element will be inserted. Only the pop out operation will be performed. And if we consider as a first F and thereafter E will be pushed, so E will be pop out first, thereafter F, so E and F. So this is the sequence. And in base first search from A we can insert B and C, so B and then C. So that after that A will be go to the visited array, remove, and B will be is at front position. So again from B we can move D, so D will be come into the rear position. Okay, so B will be remove and come into the visited array. Right now C will be is at front position. So from C E and F will be inserted. So E and F will be insert at rear position. So C will be remove and front will be increment and take at D position. Okay. Then C come into the visited array. So from D, no new node is can be inserted. So D will be removed. That means front will be increment and come into the E position. So D will be come into the list of visited array. And thereafter E and F both will be removed from the queue and stored into the visited array. So this is the sequence A, B, C, D, E. So these are the process. Okay. Thank you. So this PPT, I want to share this PPT to you by the Google Meet class. Okay. Sorry, Google Classroom. Okay. So today, thank you. Any question from your side? Any question?
স্যার গ্রাফের পিডিএফটা স্যার শেয়ার করবেন না?
হ্যাঁ হ্যাঁ, করে দেবো।